Alright, this is 9-6 in advanced geometry. Today we're doing dilations, and a dilation is going to make something either get bigger or smaller. You can kind of think of it like if your pupils get dilated, you know, they get bigger or smaller. So it is not an isometry, and here's what they tell us to do. They say use the figure and point C. Use a ruler to draw the image of the figure under a dilation with center C and the scale factor R as indicated. So they give me a scale factor right here. Here's the thing, if the scale factor is more than 1, this thing's going to get bigger, which we call an enlargement. Or if the scale factor is less than 1, that thing's going to get smaller, so that's a reduction. So we figured that out first, that since the scale factor is bigger than 1, this is an enlargement. So we put that right here. And then what we do is we just need to measure how far away is this shape from point C. Well, let's put 3 vertices on here since they don't give them to us, A, B, and C. And we'll just take a straight edge and we'll connect from C through A. And all you got to do is take your ruler and measure how far that is. And on your paper, when you measure how far is C from A, it should be about 1.4 centimeters. Please measure that, make sure you get that right number. Well, all you got to do to that is take that number times your scale factor, and in this case our scale factor is 2. So if this is 1.4 centimeters right here, then double that to 2.8 centimeters, and still with your ruler on this line and 0 line up with C, just go to 2.8 and put yourself a prime point for A prime. So this distance was 1.4, that distance right there is twice as much, so 2.8. And then let's do that again for B. Just measure how far away is this point B from C. And I measured it at 2.3 centimeters. So we'll double that and go to 4.6 centimeters, and that's where B prime will end up being. If I'm going too fast for you, you can always pause the video. And then let's measure how far C away is. You can see that I made a bad mistake. I shouldn't call this point C if there's already a point C in the picture. I apologize for that. But measure how far away this point is from there. And I got 1.5 centimeters, so that means go to 3 centimeters and put yourself a C prime there. Then all you got to do is take your straight edge and connect those together, and you can see that the pre-image to the image is not the same size, same shape, so they are not congruent, but they sure are similar to each other with a scale factor of 2 to 1. Right, so pretty simple. Let's do that again. Here now we got to figure out if it's an enlargement or a reduction. So this is less than 1, so it's going to be a reduction. And again, I labeled my 4 points A, B, C, and D, and I shouldn't have done that because I have a point C in the picture. But take a straight edge and connect from C through A and just measure. And I measure it at 2.4 centimeters. Well, you could take that times 1/4, but we're trying to stay away from that fraction button in our calculator. Instead of multiplying by 1/4, instead of taking 2.4 times 1/4, the same thing is dividing by the reciprocal of that number. So you could just plain old divide it by 4, and you get 0.6 when you do that. So that means go to 0.6, put yourself an A prime, and then do that again for B. And how far was B? Whatever that distance was, I think it's 3.8. Just divide it by 4 and put yourself a B prime. And then continue on with this. It's pretty self-explanatory once you get the hang of it. And you should get your points there. Like I said, I know I'm moving real fast, but you can always pause the video. And those two are similar figures with a scale factor of 1/4. They are not congruent, so it is not an isometry. Only reflections, rotations, and translations is an isometry. And just one more of those. The thing that's weird about it is the point C that you're doing the dilation around, it's like one of the vertices of the polygon. So figure out first if this is an enlargement or a reduction. And since this number is larger than 1, that's an enlargement. You can tell it's larger than 1 because the numerator is bigger than the denominator. So extend this dude out longer and measure how far is it from C to D. It's like 2.7. Remember, you get a little bit of leeway from all that. But you got to take it times 5/4. Well, if we're not supposed to use our fraction button, how are you supposed to take times 5/4? It's pretty simple. You just take that number of 2.7 or whatever you got times 5/4. You just put 5 divided by 4 in parentheses. Like that's how you deal with fractions when you don't have a fraction button. And you get a goofy number. Just round it to the nearest tenth, right? If these don't come out to nearest tenth, just round it. So about 3.4, you know, we'll just round to the nearest tenth. And then you just keep on keeping on. So there's D prime. And you do that again with A. And I'll let you do that. And you also do that again with B. And C doesn't move, you know, because it's 0 centimeters away from itself. So when you're all said and done here, you connect it together and it looks like so. So those are called dilations, right? It either gets bigger or smaller, an enlargement or a reduction. That's what they ask us to do here. They've already got the dilation done. They say determine whether it is an enlargement or a reduction if it went from K to K prime. Well, here's K, and here's K prime in problem number 4. Didn't that get bigger? So this is an enlargement. They say find x and find the scale factor. Well, x is pretty self-explanatory. If this is x and this is 5 and the whole deal is 7, so that's got to be 2. Then the scale factor, it does make a difference. Remember, if it's an enlargement, the scale factor has to be bigger than 1. And if it's a reduction, the scale factor has to be less than 1. So, since this is an enlargement, my scale factor should be big over little because I want that to be bigger than 1. And it's the whole distance of 7, right? We're always focusing around the point that they did the dilation around. This is the point. The whole distance of 7 divided by how far is the original guy from the point of 2. So our scale factor is 7 over 2. And on number 5, here's K, here's K prime. That's a reduction because it got smaller. Reduction. And we can figure out x real easy. If this whole thing's 5 and that's 2, that's got to be 3. And then the scale factor now has to be less than 1, so I have to go little over big. Here's the point that they did the dilation around. How far is the new dude from it? It is 2. And how far is our original guy from it? It is 5. So it's just focus from the dilation point and put those two numbers and realize it has to be little over big because it was a reduction. How do you do it on a graph? Very simple. First thing you do is they give you some ordered pairs. Why don't you plot those 3 ordered pairs, J, K, and P. You can pause the video and get that done real quick. So there's the original. That's the pre-image. If the scale factor is 2, then all you got to do is take 2 times everything in your ordered pair. So if J is at 2, 4, then J prime will be at 4, 8, right? You just double both of those, take them both times 2, because that's what our scale factor is. And K prime will be at 8, 8, and P prime will be at 6, 4. So there's that, and when you get it graphed, you know, it should get twice as big. And you're doing the dilation around the origin right here. That's like that center of dilation every time. Why don't you try number 7? First, and you should have this. I know this isn't on your paper, but you should figure out where your new prime points are. You should write them down. On number 7, we graph the pre-image. And then taking all the points times 1.5, it's still going to get bigger, so they'll all go to here, and then it should look like this when you're all said and done. So the homework is all on a packet. That was a short and sweet video. Let me know if you have any questions, and have a good one.